Here we have some problems about the mean value theorem. And what the mean value theorem states is that if you have a function, let's just draw a sample function here, and you pick an interval, let's say from a right here, that's a, to b, let's say b is right here, so there's our interval. The slope of this line from a to b, somewhere on this function is going to have a tangent line with that exact same slope. Maybe more than one spot, but there's going to be at least one spot, as long as this function is continuous and differentiable over that interval. This is a little bit like Rolle's theorem. In Rolle's theorem, a and b had the same value, and so the slope of that line was 0, and Rolle's theorem stated somewhere then the slope has to be 0. So this is an extension of that. So no matter what this slope is, somewhere along this function there will be a tangent with that same slope. And our job in these problems is to find that point. Let's take a look at this first one. So here's the way the problem is stated. We have f prime of c. C would be the point where the slope is the same, of the tangent line is the same as this slope here. And then here we just have the slope of this line between a and b. So f of b minus f of a, that's the difference of the y-coordinates, or the rise, and b minus a is the run, so rise over run is slope. And in this case, our function f of x is x to the 4/3. So what we want to do here is we want to take the derivative of this function, and we want to set it equal to the slope, and then we can solve for x, and that will be our value c, where the slope of this line is equal to the slope of the tangent line, or the derivative. So let's take the derivative of x to the 4/3. This is a simple application of the power rule. So f prime of x equals 4/3 times x to the 1/3, subtracting 1 there. So we have 4/3 x to the 1/3, and that's going to equal this chunk here. So what is f of b? We need to plug in our b point in our interval, and our interval is from 0 to 8, so I'll plug in 8 into this function. And let's see, we'd take the cube root of that, that'd be 2, and then we'd bring it to the 4th power, that would be 16, so that is 16 minus f of a, and that's 0, so 16 minus 0, and then b minus a, so that's 8 minus 0. So this is 16 over 8, or 2. So we have 4/3 x to the 1/3 equals 2. And I'm going to multiply both sides by 3/4. And we get x to the 1/3, this just equates to 1, equals 6/4 or 3/2. Now, to continue solving for x here, we can cube both sides. So we get x equals 27 over 8. And that is our value for c, 27/8. Let's try one more. So here we have again the mean value theorem problem, and we have this function, the square root of x minus 5. And we want to think for a minute on the interval, and our interval is 9 to 21, is this a continuous and differentiable function? Well, the square root of x minus 5, the square root function starts at 0 and kind of goes up like that. X minus 5, it would start a little further on, at 5 specifically. But from 9 to 21, it's going to be slowly sloping up. So this looks like a continuous and differentiable function on that interval. So we can go ahead and take the derivative of this and then set it equal to this slope formula up here. So let's take the derivative, and I think I'm going to rewrite this function first as x minus 5 to the 1/2 and apply the power rule. So f prime of x would be 1/2 times x minus 5 to the negative 1/2, and then we would multiply by the derivative of the inside, but the derivative of the inside is just 1. So we have 1/2 x minus 5 to the negative 1/2, and we could rewrite that as 1 over 2 square root x minus 5. So that's our derivative. Now let's set up our slope formula here. We've got f of b, so we're going to plug 21 into this formula. So 21 minus 5 is 16. Take the square root of that, and we get 4. So f of b is 4. F of a, we're going to plug in 9. 9 minus 5 is 4. Take the square root of that, it's 2. So we get 4 minus 2. And now b minus a on the bottom, so that's 21 minus 9. And we're going to set our derivative equal to that. So 1 over 2 times the square root of x minus 5. And we can simplify this a little bit. So 4 minus 2 is 2. 21 minus 9 is 12. And we get 1/6. And what I think I'm going to do here is go ahead and cross multiply. So 6 times 1 is 6. And 1 times 2 times the square root of x minus 5 is 2 times the square root of x minus 5. And then I'll divide both sides by 2. And so we get 3 equals square root of x minus 5. And then we'll go ahead and square both sides. So we're going to get 9 over here, and we're going to get x minus 5 over here. We add 5 to both sides, and we get x equals 14. And that is our c value. So we can say c equals 14, and that is the point where the slope of the tangent line is the same as the slope of the line connecting points A and B on the interval. So that's a little bit of work with the mean value theorem. My name is Larry. I'm a teacher at EdVision's Off Campus. It's an online project-based school in Minnesota. If you're interested, you can check us out on the web at lovethischool.org. Thanks.